All right, which action shows concern for the environment with regards to the resources of the oceans? All right, so when we talk about resources of the ocean, there are medicines that we get from the ocean. We get minerals from the ocean. We get food from the ocean. That's all I can think of right now. We also get fossil fuels. I'm not super happy about it, but we get fossil fuels from the ocean. If you want to know why I'm not super happy about drilling in the ocean, look up what happened. Well, it might be about 10 years now. In the Gulf of Mexico, the BP oil spill in the Gulf of Mexico. Let's see here. Which action shows concern for the environment with regards to the resources of the ocean? Developing technology which will allow for an increase in fish harvesting. That does not show concern. That shows greed. Okay? Now, if it said developing technology that will decrease the number of dolphins that are hurt, or the number of sea turtles that are caught in nets, okay, fine. That shows concern. But this just says increase in fish harvesting. Okay? That doesn't show concern. That shows greed. Allowing factories to release untreated wastewater into the ocean. So just whatever is in the wastewater is in the wastewater, and now it's in the ocean. That either shows laziness or greed, or maybe both. Okay, because they don't want to pay the money to clean up the water before they put it back into the ocean. Down in Florida, I got really upset with them. Not that I'm not a Floridian, I can't do much about it, but I got really upset because not only did they have these giant millions and millions of gallon ponds of wastewater that was, it's radioactive, it's toxic, and then it springs a leak. So then they pump the water straight into the bay, into the ocean, and so that's just, those bays are probably estuaries, and estuaries are nurseries for a lot of ocean-going species. So, and that's one of those chain of event things. So let's say you have an estuary here, right? Here's your estuary. Now, there's out here in the ocean, there's some kind of fish, right? And this fish, it lives in the ocean, but it travels to the estuary to mate and lay its eggs. So if we pollute this, okay, the babies can't survive. So the numbers of this fish decrease because its nursery is polluted. But what if that's a fish that the commercial fishermen fish for? Well, now their supply has gone down. So they could be out of business. They could be bankrupt and not able to earn enough money to feed their families, right? Not to mention, as the supply of the fish goes down and the people fishing for it goes down, the price of that fish is going to go up. So then when you go to McDonald's and you want a fish fillet, or you go to a fancy restaurant and you order some tilapia or something, it's going to cost more. Okay? Environmental issues are not just environmental issues. They are economic issues. They are citizen issues. Okay? They don't just affect the environment, they affect everything. Anyway, I got off track there. Filling in oceanfront wetlands in order to extend beachfront properties. All right, I'm going to tell you why that's dumb. All right, so wetlands, We talked about this in another video, so I'll be quick. Wetlands filter pollution out of the water naturally. They also soak up floodwaters. All right. So wetlands are important. Filling them in is like one of the worst things we have done as a species. So that's greed. Ignorance and greed, probably. At one point, I think people really didn't understand why the wetlands are important. Okay? Now we do. So that sort of thing needs to stop. Setting limits on fish harvesting in the oceans. Ding, 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 ding. Okay? There are size requirements, how big a fish can be for people to keep it. Whether you're just out fishing with your buddies or whether you're a commercial fisherman. There are times, like seasons, where you can fish or not fish in certain areas or certain types of fish. There are limits on how much you can catch, especially for commercial fishermen. So that shows a concern for the environment because you're trying to protect those species. Because look, if there aren't enough adult fish to mate and reproduce and have babies, you're going to run out of that organism, that species. All right, 46. What effect does the water cycle have on the total amount of water on Earth? Here's the thing. The total amount of water has stayed the same for like 4.6 billion years. Okay? So I'm just going to tell you that's the answer. The total amount of water on Earth has remained relatively constant. Okay? The water we have now is the water we're going to have in 100 years, in 1,000 years, in 1,000,000 years. Okay? There's no natural process for making new water. The water evaporates, it condenses, it precipitates, it evaporates, it condenses, it precipitates. That's just the way it works. Now, real quick, remember 97% of all the water on Earth is salt water. Okay? Of the 3% that's fresh meaning no salt, okay? 2%, 2 of those percents is frozen. You have about 0.9% that's in the ground, and you have 0.1% that's on the surface. Okay? So we have a lot of H2O molecules on the planet. We really do. Okay? Most of it, though, is salt, and we can't drink it. And of the fresh water, most of that is frozen. And so that 1% that is in the ground and on the surface, more and more and more of that is getting polluted. Okay? And it's not deer that are polluting it. It's not polar bears that are polluting it. It's humans. Okay? There's no denying that. How did antifreeze end up in this pond? Humans. They may not have dumped it directly, but maybe they poured it out in their yard and it washed down the sewer drain or the storm drain. Okay? Maybe they had a leaky radiator and they either could not or chose not to get it fixed. And it leaked on the highway, and then it rained, and it washed into the storm drain and into the river. Okay? That's the only way. That's how it gets there. So everybody has to do their part. Okay? We got to hold big corporations accountable for doing illegal or unenvironmental things. But we also have to keep ourselves in check. Which characteristic of water quality provides the most information regarding the health of a water system? Okay, So let's talk about indicator species, because that's the answer. Okay, indicator species. Let's talk about them real quick. All right, let's say you have a river. All right, here's my river. Now in this river, I have some salamanders, lots of salamanders. All right, and then I also have some mosquito larvae. Now here's the thing. Salamanders are really sensitive or intolerant of pollution. Right? Mosquito larvae, they don't care. They are very tolerant of pollution. Okay? So, if I were to look at this river and I see salamanders and I see mosquito larvae, no big deal. But let's say I come back every year and I check this river, and over time I see fewer and fewer salamanders. Okay? That would be an indication that there's something wrong with the water. There's some kind of pollution. Because if all you have are lots of very tolerant species and the intolerant species are being wiped out, then that tells you that there's some kind of pollution. Now, it could be thermal pollution. It could be acid rain causing the river pH to change. It could be chemicals. It could be lots of different things. But so intolerant species like salamanders are called bioindicators. And they're called bioindicators because they indicate that there is something wrong with the river system or the water. It could be a pond or a lake. It could even be a forest. But in a forest, you're probably not going to have, you're not going to be looking for salamanders. All right. Where is most of the Earth's fresh water located? Well, we just said, okay, 97% is salts. That leaves 3%, right? And that 3%, 2% is frozen, some kind of ice. About 0.9% is groundwater. Okay? And then that 0.1% is on the surface. So you tell me, where is the majority of Earth's fresh water? Now that's the key thing there. Fresh water. Okay, where is the majority of Earth's fresh water? All right, which is the most accurate way of determining the age of a fossil? All right, so we want the most accurate. Now we can figure out, all right, dating index fossils and dating rock layers, those, we're going to throw those out, okay? They're not completely wrong, but they're not the best answer, all right? Remember, relative dating is going to give you a relative age. This fossil is older than that fossil. This fossil is younger than that fossil. That's relative dating. Radioactive dating is a type of absolute dating. So it gives you an absolute age. Another way of saying that is it gives you numbers. So if someone says this fossil is 3.2 billion years old, that's an absolute age, most likely found through radioactive dating. If someone says this pottery is 10,322 years old, they know that because of radioactive dating. Okay? They looked at probably carbon-14, which allows scientists to investigate. So you tell me, is it radioactive dating or relative dating? Number 50, which allows scientists to investigate what Earth's climate was like over the past 740 years. All right, so we want to know about past climate. Now, volcanic deposits, probably not. Faults, no, that doesn't tell us anything about climate. It tells us something about plate tectonics, maybe. It doesn't tell us anything about climate. Volcanic deposits, I mean, if we find volcanic ash on a global scale, that could tell us something about a short period of climate change. But as far as I know, we haven't found global deposits of, that all occur at the same time. So that leaves us with fossils and ice cores. Now, fossils tell us a little bit about climate in particular areas. For example, there are plant fossils and reptile fossils in Antarctica. Okay? Antarctica is way too cold for plants and reptiles. So that tells us at some point it was closer to the equator. But again, that doesn't tell us a lot about climate. It tells us about the past climate of that one continent. Okay? But if we look at ice cores, we can find out by looking at those trapped gases. So as soon as you see the word ice core, I want you to think past climates. And I want you to think trapped gases. Okay? And because the trapped gases in ice cores not only tell us about the temperature of the atmosphere thousands and thousands of years ago, even hundreds of thousands of years ago, it also tells us about the amount of carbon dioxide in the atmosphere. Okay? So we can make predictions about those past climates based on the trapped gases in the ice cores. All right, I'm at 17 minutes, so I'm going to cut the video, and I think I'm on part 6 now.